Who? I fixed it. Ignore me. I was confusing 18 and 18 is the total length that we started with. Length is just that piece once you start cutting, and that's the H because once you fold it up. Yeah, that's it. So 18 is H plus L. 18 wasn't L. 18 is just the total combined. Okay, cool. Never mind. I got a little lost. It's late at night. But anyways, so that's our length because there's our L right there, and there's our H. Okay? That gets folded up, and that becomes that length right there. And that's the H, and all of it together is 18. So now we know that 18 is equal to 2H plus L. Okay, so now we can use that 18 is equal to 2H plus L and substitute in there. So, at this point, you just take your pick. Do you want to solve for H or do you want to solve for L? I'm going to choose to solve for L because that's just what I want to do. And that's okay. So we take equation number 2 and we substitute it into equation number 1. How does that look? Well, we know we have an expression for L now. So we do 18 minus 2H squared times H. Well, let's recap. Before, we had volume that changes with length and height. But now, using our second constraint equation, it's not changing with length and height anymore. It's just changing with height because the length depends on the height. See that? We kicked out the L, we put in some function of H, and now we have something to work with. So, at this point, we do dV per dH. Let's do some product rule real quick. F prime G, G prime F. That'd be 2 times 18 minus 2H times chain rule gives us negative 2 times H plus F 18 minus 2H squared. The derivative of H is just 1, so that stays like that. Okay. So now what we want to know is where is dV over dH equal to 0? Where is that derivative equal to 0? Because once we find that, we can find our critical point. So I guess what this problem is really asking us, where is 218 minus 2H, negative 2 times H, equal to negative 18 minus 2H squared? See that? I set that equal to 0, and I brought this to the other side. I can do some algebra and cancel out the 18 minus 2H. So once you do that, it looks a little something like this. You get negative 4 times H is equal to negative 18 plus 2H. Let's do some more solving. We get negative 6, is that right? Negative 6H is equal to negative 18. And if my math is correct, H should equal 3 inches. And bada boomba, there you go. A quick thing about word problems. They're going to want you to set up a sign chart. I really recommend setting up a sign chart. What a sign chart means is you take your number line, right? You set your critical point somewhere. In our case, it was 3. For our derivative, we know it's going to be evaluated at 0. But let's pick a number to the right of 3. Let's say, I don't know, 1,000. If you plug in 1,000 here, if you plug in like 1,000 here, what's going to happen? Well, that's going to become a really, really positive number. And that is going to become a really, really, really negative number. That's going to be negative. That's going to be negative 1,000 times 1,000. So what happens is you get a negative number on this side. And then if you do the opposite, if you plug in negative 1,000, you get positive on this side. So you get increasing, decreasing. Now, the whole 1,000 or whatever that I picked, that's me. I like picking big numbers because it helps me see what the sign is going to be. For those of you that didn't feel comfortable with that, pick 4 or 5. Pick numbers that you can actually plug into your derivative and you can get a number for. Because if I pick 4 or 5 or 6 or 7 or any number to the right side, they're all going to give me the exact same sign. If I plug in any number to the left, whether it be 2 or 1 or 0, they're all going to give me the exact same sign. They're going to be positive. In this case, if I plug in 0, let's see what happens. 0, so this whole thing's being multiplied by 0, so that becomes 0. And then I have 18 minus 0 squared. Boom, that's positive. I picked 0 because that was the quickest thing I could solve for. Any number works. Pick one, see its sign, boom, there's your answer. Just make sure your algebra is good to go. Okay, so we see that it's the maximum, but it was going to be the maximum anyways because that's how word problems work. But make your sign chart anyways. They're going to want to see that, so get used to making that. It's very helpful. So now we see that h is 3 inches. That's where our maximum occurs. Are we done? Well, kinda, yes, no. The problem said, what should the dimensions of the box be to maximize volume? Well, the dimensions of the box are the length and the height. It's also the width, but the length is the width. So what we really need is the length and the height. Well, we have the height. So how do we get the length? If you ever get stuck, a nice tip, a helpful tip, is go back to the beginning of the problem and reread what they're telling you. Or, you know what? Just go back to your equations. Does that equation help you solve for length from height? No, it doesn't. Does that? No, sir. Does that? Yes, sir. Because now we know that 18 is equal to 2 times 3 plus L. So L is equal to 18 minus 6. L is equal to 12 inches. And if they asked you for what the maximum volume would be, well, you have length, you have height, plug it into your objective function, which is what you were trying to solve. So volume would equal 12 squared times 3. And you know what? I'm kind of shitty at algebra. So whatever that number is, that's your maximum volume. That was an easy optimization problem. I kind of got tripped up here. But I want to show you one that you guys haven't done in class, and it's a little trickier to think of. It'll be in a separate video. I'll title this one Optimization Part 1. That'll be Optimization Part 2. This one's a really good problem to just get the concept of it, but there are definitely other problems out there that they can trip you up. Message me on Snapchat if you have any questions about this.